Welcome to section 6.1. In this section we'll be discussing inverse variation. We're asked to express in our own words the meaning of each vocabulary term. Inverse variation simply tells you how two variables are related to one another. It also, if it's inverse variation, then that indicates that as one variable increases, the other variable decreases. So you can say that. You can say as one variable increases, the other variable decreases. And then we have constant of variation. Constant of variation just tells you basically if one variable increases as the other variable decreases, your constant of variation just tells you by how much. An example of constant of variation might be, it's like slope. If you think about the slope of a line, let's say if you've got a line that, I don't know, maybe it's like this. If you've got a line like this, okay, you'd have a negative slope, and it would tell you that as one variable increases, the other decreases. So you could just think of this as like slope if you want to. It's similar. You can say it's similar to slope of a line. And for the core concepts, inverse variation, two variables x and y show inverse variation when they are related as follows. Y equals a over x, where a does not equal 0. Okay? The constant a is the constant of variation, and y is said to vary inversely with x. Okay? So we're going to just jump right into some examples of this topic. I feel like you've probably seen this before. So in the directions here, we're asked to tell whether x and y show direct variation, inverse variation, or neither. Okay, so if it's direct variation, then you would see something like, it would look like y equals a times x. That's for direct. So in number 1, we have to solve this for y. We've got to get the y by itself first. So to do that, let's divide both sides by 3x. So that leaves me with y equals 1 over 3x. Well, because x is showing up in my denominator, and I don't have any additional terms out here, this is a version of inverse variation. And inverse variation looks like y equal my constant divided by x. Okay, so because it was similar to this, where I'm dividing by x, this is an example of inverse variation. In number 2, I have 5 over x equals y. That is exactly the way they defined inverse variation. They just wrote it the other way. So you can say, if you prefer, you can write it y equal 5 over x. Because I'm dividing by x, this is inverse variation. I think I'm going to abbreviate it because I'm a little cramped on space here. Number 3. So it needs to be solved for y. So x plus 11 equals y. You can think of that as y equal x plus 11 if you want to. But because of this additional term out here where we're adding 11, this does not fit the definition of inverse variation that we saw on the first page. So my definition looked like, I lost my paper. Oh, I know where it is. Here. So the definition that I was given, y equals my constant divided by x. If it looks like that, if I'm dividing by the other variable x, then I've got inverse variation. So this one in number 3 has this additional term out here. So this one is neither. Okay, it has to look like one of these up here to have actual variation. Number 4 If I solve for y, subtract x on both sides. It gives me y equals negative x minus 2. Because of the extra term out here, this is neither. Number 5, y equals 4/5 x, so you can rewrite it the other way if you want to. Because x is being multiplied to the constant, x is not in the denominator. So this one would be direct variation. I'm just going to put dv. Number 6, I need to solve for y. So I can subtract x on both sides. So I have negative 8y equals negative x plus 1. Divide both sides by negative 8. And that gives me y equals positive 1/8 x, or x over 8, either way. And then that would be minus 1/8. Okay, so because I've got this extra term out here on the side, this is neither. Number 7, I don't know why they wrote every one of them backwards, but y equals x over 7. That is an example of direct variation. It's got a fraction in it, but because x is in the numerator, this will be direct variation. In number 8, I need to solve for y, so I can divide both sides of this by 6x. That gives me y equals 0 divided by 6x would be 0. So this was neither. And then for number 9, I need to solve that for x. Excuse me, I need to solve that for y. To do that, I can multiply both sides by my common denominator, 9x. So if I multiply both sides of this by 9x, I'm getting y equal 1 times 9x. So I can see that this is direct variation. Okay? So you're just checking to see which form it's in. It's got if it's a constant divided by x, it's inverse variation. If it's a constant times x, it's direct variation. I'm going to skip the tables and just move on to the next topic. So we're going to go on to number 13. In number 13, they tell us the variables x and y vary inversely. Use the given values to write an equation relating x and y, then find y when x equals 5. Okay, so if x and y vary inversely, then that means that you can write it in the form y equals a over x. I'm going to substitute in the numbers that I was given. So 2 goes in for x, 2 goes in for y. That allows me to solve it for my constant a. So I'm going to multiply both sides of this by 2. Multiply here, and I get 4 equals a. So my constant of variation is 4. So I'm going to put 4 back into the original equation that I set up. So like that was step 1, and now I'm on step 2. Y equals, put 4 in place of a. So y equals 4 over x. And then for step 3, they want me to do something with the equation that I just got. This equation has a name. If I can remember what it is. It won't come to me at the moment, but this equation does have a name. But they want us to find y when x equals 5. So I'm going to substitute 5 in for x, and I get y equals 4 over 5. So y equals 4/5 would be the final answer there. For number 14, again, they told me that x and y vary inversely, so I'm going to set it up as y equals a over x. Then I can substitute. I put 3 in for y, and I put 6 in for x. If I multiply both sides of this by 6, I'm going to get 6 times 3, and then multiply over here by 6. So these cancel, so I'm left with 18 equal a. So I found the value of my constant, and then in step 2, I put 18 back into my equation that I started out with in step 1. So I'm going to say y equals 18 over x. And for step 3, I need to put 5 in for x to solve for y. So y equals 18/5 is my answer. Number 15, same directions. This time we're going to say y equals a over x. That's step 1. Substitute in, so we're going to put 7/20 for y. We're going to put 20 for x. Okay, so if 7 over 20 equals a over 20, the denominators are the same, so the numerators will also be the same. So this means that a equals 7. Once I have my constant, I go back to step 2, and I say y equals 7 over x. And then for step 3, I'm going to find y when x equals 5. So y equals 7 over 5, so my answer would be 7/5. For number 16, it varies inversely, so y equals a over x. For step 2, then substitute in. So y is 3/2. And a over, and then for x, I need to put in 10/9. Okay, so we've got a fraction inside a fraction. Okay, but that's okay. We can still multiply both sides by 10/9. So if I multiply 3/2 by 10/9, then I've got 3/2 times 10/9, and if I multiply this side by 10/9, they cancel. So I'm left with a, and then I can simplify this. That would be 5/3. So I've got a equals 5/3. Then I need to put that back into the original equation that I started with. So y equals 5/3. So 5/3 divided by x, I can just write as 5 over 3x. And then I'm going to use this equation, 5 over 3x, to find y when x equals 5. So I'm going to put 5 in for x. I'll have y equals 5 over 3 times 5, and that will give me y equal 1/3. Okay. I'm sorry, I ran off the edge there. So that's all my work for what I did. And I've debated about doing it on a separate sheet of paper. It depends on how big you write. These pages don't give you a lot of space. Alright, so let's look at number 17. When temperature is held constant, the volume V of a gas is inversely proportional to the pressure P of the gas on its container. A pressure of 32 pounds per square inch results in a volume of 20 cubic feet. What is the pressure if the volume becomes 10 cubic feet? Because I'm so limited on space, I'm going to do it on a separate sheet. Now, even though this is a word problem, you're going to do the same exact procedure that we did on the earlier problems. They've given us variables to work with for all of them. So we're just going to kind of concentrate on those variables. So, alright, so there's a lot of it, there's more information here than I actually need. So let's find what we really need to concentrate on. When temperature is held constant, the volume V, so that's a variable, we'll circle it, of a gas is inversely proportional. Okay, inversely proportional is important. That tells me how to set up the problem. V is inversely proportional to the pressure P. Okay, so that's what I need right there to set up the equation. I'm going to say V is inversely proportional, so that means equals my constant A divided by the variable that follows P. Okay, so V varies inversely with P. A pressure of 32 pounds per square inch results in a volume of 20 cubic feet. So what's happening here is I'm given all the information that I need for the variables so that I can solve for my constant. So I'm going to substitute in 32 for P. So we're going to let P equal 32. So basically you could think of it this way. P equals 32 when V equals 20. So we'll substitute that in and solve for A. So 20 equals A over 32. I'm going to multiply both sides of this by 32. That gives me 640. So A equals 640. Now that I have a value for A, 640 goes back into this equation. So so step 2 now is I'm going to write the equation V equals 640 over P. And with this equation, I can finish it. And I wish I could remember the name of that equation. It'll come to me after I finish recording this. So finally, they want to know what is the pressure if the volume becomes 10 cubic feet. So for step 3, we need to find P when V equals 10. So we'll just substitute that in. So we're going to say 10 equals 640 divided by P. Multiply both sides by P. So I've got 10P equals 640. And then divide by 10. P equals 64. So, and then the units, I believe, for the pressure, the units were pounds per square inch. I believe that can be written as PSI. So my answer is 64 pounds per square inch, PSI. I apologize about my camera not wanting to focus. Okay, so that was number 17. So that was all the work that I did for it. And for number 18, let's look at that one. Number 18. The time T in days that it takes to harvest a field varies inversely with the number N of farm workers. A farmer can harvest his crop in 20 days with 7 farm workers. How long will it take to harvest the crop if he hires 10 farm workers? Okay, so what do we really need? We need T for time. It varies inversely with N, the number of workers. So that's our equation right there. Let's see if I can get this to straighten up. So we're going to write T equals K divided by N. And then in the second sentence, they're going to give you the information that you need to solve for K. I'm sorry, I just goofed up. Did I do that in the last problem? No. I have always been in the habit of using the letter K for my constant of variation because that's what the textbooks I've taught from have used. So I need to change that. T equals A over N. Okay? So in the second sentence, they're going to give us all the information that we need so that we can solve for our constant A. A farmer can harvest his crop in 20 days with 7 workers. All right, so we're going to substitute in 20 for T and 7 for N. 20 equals A over 7. Multiply both sides of that by 7. So 140 equals A. And then I can write my equation that I need from here. So I'm going to say T, so this is step 2 now. T equals 140 over N. And use this equation to finish the problem. What is the pressure if the volume becomes 10 cubic feet? So I'm going to put in 10 for, I'm sorry, I just read the wrong one. The question is, how long will it take to harvest the crop if he hires 10 farm workers? So I'm going to put in 10 for N. So T equals 140 over 10. So T equals 14. So that would be 14 days. Okay? Alright, so that's it for the notes for section 6.1. However, I am going to do an example. I'm going to assign this enrichment page to go along with it, because this is what you'll see if you take 171. You'll see problems that look a lot more like this. Alright, so let's let's talk about this. So combined variation, what does that mean? Let me see if I can zoom in. Okay. Combined variation can be used to describe the relationship between three or more variables that vary directly and inversely with one another. You can solve combined variation problems by writing a combination of variation equations and using the given values of the variables to solve for the constant of variation. So, in other words, let's look at this example. It says that the variable y varies directly with, I feel like this is so blurry. I don't know if it's showing up on here, but you've got it on your own paper, but still. Okay. The variable y varies directly with x and w, inversely with the square of z. Okay, and then they go on to give us numbers to substitute in for all of the variables. Okay, so just looking at the first part. Y varies directly with x and w, inversely with the square of z. Okay, so we're going to look at that very carefully. Long story short, if it says varies directly, you're going to multiply your constant a by whatever variable follows it. And if it says inversely, then you're going to set it up as your constant a divided by whatever follows it. So I would write y equals a times, it varies directly with x and w. So multiply that together. And it varies inversely with the square of z. So inversely means we need to divide, and then we need to divide by the square of z. Be really careful here. A lot of times people misread that as square root of z, but that's not what it's saying. The square of z means z square. So this is how we set it up initially. They're going to give you everything that you need in this next part to solve for your constant a. So they give us y equals 100. So this was step 1. We're going to substitute in 100 for y, x equals 2, w equals 4, z equals 20, and we have to square the 20. Okay, so we're going to just solve this for a. You've got 100 equals, that would be 8a over, and 20 squared would be 400. Multiply both sides by 400, and that's going to give you 40,000 equals 8a. And then divide both sides by 8. And then, what's that? 5,000. So my constant of variation I found to be 5,000. So in step 2, I'm just going to substitute the 5,000 back in here for a. So I've got y equals 5,000 x times w over z squared. And then usually they want you to, in this case they don't. This time they only said to write an equation relating w, x, y, and z, so that's what we've done. In many cases they're going to, at this point, ask you to find one of the variables if you've got certain values to substitute in for all the other variables. Okay? So what you're going to be doing is, part of your assignment will be to complete these problems 1 through 4 on the 6.1 enrichment and extension. And you will also be doing in your textbook, so your assignment for all of this is the enrichment and extension, as well as the 6.1 textbook page 311, problems 3 through 10, 15 through 22, and 25 and 26. Okay, And that's it for section 6.1.